You know, one of my favorite places here at the Girl Scout STEM Center of Excellence is the outdoor soundscape. And that's because we can explore some really interesting but hard concepts in a fun and engaging way. Let's talk about sound. There's frequency, there's pitch. Those are all things that confuse me, but when I'm playing these xylophones, I get a really good idea of how those things are related. So check out this here. We've got this xylophone made out of wood, and the bars are all of different lengths. Let's find out if we can find a relationship between the way it sounds and the length of the bars. We'll try that one more time. So what I notice is that as we play these bars from the short end to the long end, the pitch changes. And what I'm hearing is that the shorter bars have a much higher pitch than the longer bars. Do you hear that? So why is that happening? Well, these shorter bars are able to vibrate at a much higher frequency. And the higher frequency relates to a higher pitch of sound. And you'll notice it. So this is a great example of how pitch and the length of a vibrating object are related. We've got another set of xylophones over here. This one's made out of slate. We were listening to the wood ones. Now let's check out how this material might affect the sound. I think we see the same relationship between the length of the bar and the pitch. But one thing that I notice, for the same length of bar on the slate xylophone and the wood xylophone, we're getting a much higher pitch on the slate xylophone. Now, why might that be? That's because these slate bars have a much higher density than the wood bars. And that means that there's a lot more material in the same space that's vibrating. And so more vibrations equals higher frequency equals higher pitch. I'm inviting you to come out here and explore all the different ways that sound and music come together. And that's talkSTEM.